Okay, so the purpose of this video is to try to explain a little bit how do you set the live steam parameters of a steam power plant and what influences it. And basically, it comes down mostly to two things: condensers and fuel. So fuel is pretty straightforward. We talked about it a little bit on the first lecture, but the condenser might be at first thought a little bit far away from the live steam parameters and might not be so obvious why that is such an important influence. But basically, it comes down to it that the available cooling water temperature, that's what fixes the exhaust pressure from your turbine. Now, as we said, live steam temperature is limited by fuel characteristics, and then between the live steam and exhaust to the condenser, you're going to be expanding at some isentropic efficiency, and that doesn't have a whole lot of variability of what it might be. So your turbines are from whichever manufacturer, they're pretty much similar in terms of what kind of efficiency you can get out of those. And that really means that if you want to get certain level of steam quality at the end, not too wet so that you would damage the turbine final stages, but also not so dry that you're kind of wasting heat by removing heat that could be converted to energy, then there's not a whole lot of room left in terms of how you can select the live steam pressure. So in terms of how to think about it, well, what would be a good initial first try if you, for example, think about how to solve the assignment? One of the very first things you have to do there is to set your live steam temperature and pressure. So, okay, you can figure out what is going to be your exhaust pressure. Okay, that's going to be set by the district heating water temperature, in this case, the supply temperature. Then you can come up with a pretty good idea of what your pressure is going to be. And then from whatever pressure you get, you try to go upwards at some angle, a little bit tilting to the left until you get to the kind of temperature you think is reasonable. And for what is reasonable, you can take a look at those figures at the end of the assignment task. And there was also something in the third lecture, quite in the beginning, when we talk about the boiler. And then after you've selected your initial set of values, you calculate the expansion of the turbine to check that does it really end at some reasonable good area. So I would highly recommend to try to aim at something that is between 90 and 95%. So this is the part one of the assignment. That's going to be part two, and making sure that it's above 90% is going to make your life a little bit easier for the second part. But all right, let's look at an example of how it might go. Suppose that somebody has already figured out what might be your live steam parameters, and now we start from the point of view that we try to figure out what is this set of parameters good or not. So we're given 530 degrees Celsius temperature, 180 bars pressure, expansion at 85% isentropic expansion efficiency. And we know that the cooling water is available at 5 degrees seawater. The water is going to be heated by 10 degrees in the condenser, and terminal temperature difference is 5 degrees Celsius. So first we use this information to check that is our expansion going to end at a reasonable area. So we need to figure out what is going to be our exhaust pressure. And that begins by drawing the temperature diagram of the condenser. So remember, it looks something like this. And now we know inlet temperature 5 degrees. We know that the water is heating the condenser by 10 degrees, and we are told that terminal temperature difference is 5 degrees. So that means that 5 degrees on top saturation temperature at which steam condenses is going to be 20 degrees Celsius. And then we take a look at the HS drawing, the backside saturated vapor lines, and we check what is going to be the pressure, and we will find that the pressure is 22 millibars, so 2.2 kilopascals. All right, So now we see where that 2.2 kilopascal line is in the HS drawing. Then we check the 180 bars, 18 megapascals, and temperature is 803 Kelvin if it's 530 Celsius. And then we can draw our expansion line with the isentropic expansion efficiency as we have now learned to calculate many, many times. And we realize that we end up at something like 0.815 steam quality. So that is very, very wet, and that is definitely going to destroy our turbine blades too soon. So we need to do something. Now the question is, what is that something? Okay, we can play with either temperature or the pressure now. And it might be intuitive to think that, all right, we have to increase the temperature, but actually no, because the fuel is really what limits our temperature. We can't really, well, there are a few things that you really can't do, but it's going to be prohibitively expensive to try to increase the temperature. Either you pay a lot of money for your superheaters, or you're going to pay a lot of money replacing them very, very often. So what we do instead to move the endpoint of this curve to the right is we move the start point to the right along the same temperature curve. So we reduce the pressure. So starting from 18 megapascals was too much. Let's try 8 megapascals, 80 bars. Constant temperature, reduced pressure, new expansion curve, and now we are at 87. Now if we were calculating a condensing power plant, this would be quite okay. We could expect that our turbine might have a long happy life there with this kind of moisture. But as I said, for the assignment, do try to get it a little bit over 90% rather than below. Okay, that was it. Small clip. Hopefully this is going to be helpful for the assignment. Thank you.